This conference will now be recorded.
Okay, guys, let us start today's session. So the next example that we are going to see is this one. So this is a character array is there, and then this is a pointer to a character. Let's see how we can get the clarity of the example with a diagram. This is comparatively very simple compared to our two-dimensional array with pointer concept and etc. This is very simple. So the very first line is what? It's a character array. First line is a character array. Next and after that, the next line is I took a pointer type. I took a point. I'm taking a variable which is basically pointer to character. I'm basically taking a variable which is basically pointer to character. Pointer to character means its capability is to hold the address of a character. That's the meaning of pointer to character. Now let us see what is going to happen here. So first line, one character array got created. This is the character array. So for this character array, how many cells are there? 4 cells are there. 1, 2, 3, 4. 4 cells are there. So what is the content of the character array? The contents are A, B, C, D. This is the content of the character array. Now character takes always 1 byte. So that is why if the address is 10, next address will be 11, next will be 12, and next will be 13. These are the addresses for the character array. Done. The name of the character array is A. Next and after that, we are having a pointer variable. What is the name of that pointer variable? The name of the pointer variable is PPP. PPP. And what it is holding, carefully see, very easy. Ampersand A0. That means address of the first location, which is none other than 10. So it is having the value like 10. Done. Next and after that, we are having a statement like this, star PPP plus plus. Now in this line, what is going to happen? Two operator is visible. What are the two operator? One is star and another is post increment. Now post increment is having high precedence compared to post increment is having high precedence compared to that of the direction star or the pointer operator. Post increment is having high precedence. So that is why how the expression will be bracketized. The expression will be bracketized in this way. Post increment is having high precedence now. That's why it will be bracketized in this way. This part first and then this part. This is how it will be bracketized. Next and after that, now the question of evaluation comes. Evaluation is what? Value at address. Value at address. Next and after that, PPP. PPP value is what? 10. And then it's a post increment. So that means first this part will be evaluated. This value at address, this line will work. After that, PPP will increment. So, but the problem with this statement is that I'm not printing that. So it will just evaluate it. That's it. Nowhere it will be printed. Just it will evaluate it. Just the value at address 10. What is that? A. But I'm not going to do anything with that A. Why? Because it is not going to be printed. Am I audible now, guys? Confirm once. Am I audible now? Yeah. Okay. Yeah. Now come here. So this line is just evaluated, but it is not going to give me any such effect, sir, because I'm not printing that. But now PPP will increment. So PPP will increment means it will become next location after 10 is 11. Done. Next and after that, I have to evaluate this part, this one. But this time I'm going to print it. This is the expression. But here, how many operator is there? Two operator is there. One is star and another is post increment. Star and post increment both are having same level of precedence. Both are having same level of precedence. Star and pre increment both are having same level of precedence. But post increment is having high precedence. Post increment is having high precedence compared to pre increment. But star and pre increment both are having same level of precedence. Once they are having same level of precedence, we have to go for associativity. What is the associativity? The associativity rule is left to right. The associativity rule is right to left. The associativity rule is right to left. So how the expression will be bracketized? This part and then this part. Right to left I'm coming. Then what it means? Equal to value at address. What? Plus PPP. PPP current value is what? 11. Current value is what? 11. First it will be incremented. So it will become what? It will become 12. So that means what they're asking? Value at address 12. Now it got incremented. It got incremented and it is becoming 12. So it becomes value at address 12. Now you see value at address 12 we are printing with percentile C. Percentile C is for printing character. So automatically value at the address 12 is what? C. So what is going to be printed? C. Similarly, we are having another one. Minus minus. We are having another one. Minus minus star PPP. Pre-decrement. Pre-decrement and multiplication. Pre-decrement and pointer in indirection star. Both are having same level of precedence. Then associativity, sir. Associativity is from right to left. Then which part will be bracketized first? This part will be bracketized first. This part will be bracketized first. Then this part. Right to left. Now what is going to happen is equal to minus minus means decrement. Which thing to decrement? Star means value at address. Value at address. What is that? 12. What is the value at address 12? Sir, value at address 12 is C. C will be decremented by 1. If C is decremented by 1, what it means? Before C, what is there? C is decremented by 1 means before C, who is there? Definitely B is there. So what we are going to get, sir? We are going to get here as C and B. C and B. Let me check it out once. This is C. First one is C, no doubt about that. Because value at address 12, it is printed at C. Next and after that, minus minus of star PPP. Minus minus of star PPP. Minus minus and star PPP. Minus minus is pre-decrement and star is indirection star. That is called pointer operator. Pre and pointer operator both are having same level of precedence. They are having same level of precedence. Once they are having same level of precedence means what? Sir, I have to go for associativity. I have to go for associativity. Once I go for associativity, then associativity is right to left. That is why first this part is bracketized, then this part is bracketized. Next and after that, what I'm doing here? Star means value at address. Star means value at address. PPP means what? Sir, PPP means is 12. PPP current value is what? 12. So once the PPP current value is 12, what is going to happen, sir, here? Value at address 12 is what? Value at address 12 is C. So it will be decremented. Once it will be decremented, it should be printed as B. Let's see if I am making any mistake or not. Let me check it out once. Execute, compile and run. First one will be definitely C. Second one I have a doubt. Yeah, second one I have a bit doubt. That's what I was thinking here. First one is C. Let me check it out one more time. Plus plus PPP plus plus. So it become 10 to 11 here. Okay. After that here one more time it is incremented, so it becomes 12. So value at address 12. That is C. That got printed. Okay, fine. But then what is happening here? Why it is giving it as A? Let me do it one more time. Minus minus star PPP. Minus minus star PPP. So minus minus star PPP means it's pre-increment and multiplication indirection star. So this operator is having associativity right to left. So it means what? Minus minus star PPP. Star PPP is what? Value at address. Value at address. Value at address what, guys? Value at address 12, because PPP updated value is 12, right? Now value at address 12, value at address 12 is C. So C, value at address 12 is C. C means ASCII value is 65, 66, 67. 67 will be decremented by 1 means it will be 66. So definitely B should come. But how A is coming? How A is coming? Anywhere any miscalculation is happening, guys? This is star PPP plus plus plus. Okay. This is star plus plus PPP. This is minus minus star PPP. Yeah, everything is okay only. Where it got stuck. Okay, let me go for one more time. Star PPP plus plus. Here post increment is having high precedence. I bracketized it first. Then we are having indirection star. Okay, star means value at address. PPP value. PPP value means it is having the address of A0. Address of A0 means it is 10. It is having the value like 10. So it becomes value at address 10, but I'm not going to print, but PPP value will be incremented. So PPP value will become 11. Up to this is fine. Once it is fine, star plus plus PPP. Star plus plus PPP means both of them are what is called both of them are same precedence. Once both of them are same precedence, what is going to happen? Associativity will come into the picture. Associativity is for unary operator right to left. Associativity of the unary operator is right to left. You can check it from here. See, pre-increment operator and indirection operator. Their associativity is what? Right to left. Associativity is right to left. And see, post increment, post decrement is having high precedence compared to pre-increment, pre-decrement. So as per the operator precedence and associativity concern, we are going basically in the right direction. As far associativity and precedence is concerned, we are going in the right direction. Now, once the associativity and precedence are correct, once the associativity and precedence is correct, whatever it is, star plus plus PPP. So that means as per the right to left. So plus plus PPP I bracketized first. Once I make that part bracketized, after that star part I bracketized. Now while evaluation is going on, star means value at address. Star means value at address. I write there. Okay. After that, after writing that value at address, we are having plus plus PPP. PPP value by the meantime is 11 and 11 is incremented to 12. So that means value at address 12. That is perfectly happening and C is coming. With first answer, we are not having any doubt. And once the first answer 12 is coming means what? Up to this it is okay. Up to this it is okay. Now where we are making the mistake? In this part. In this part we are making the mistake. But how? How A is coming? Here again minus minus and star PPP. So minus minus and star PPP means one is pre-decrement, another is indirection star. Who is having high precedence? No question of high precedence. Associativity will come into the picture. Once associativity will come into the picture, we will go for what? We will go for right to left associativity. So as per the right to left associativity, first we bracketize the star PPP part. So star PPP part means acha, is it 1 minute guys? Minus pre-decrement. Minus star PP means one time it will be decremented. So minus value at address 12. Acha. The mistake is here, guys. Listen carefully. Printf is a function. Printf is a function, and these things are considered as argument. These things are considered as argument. Now, yeah, what happen is that inside a function, arguments are sent from right to left or left to right, but all modern day compiler follows the right to left approach. All modern day compiler follows the right to left approach. So where I am making the mistake is, observe carefully, I am evaluating this first followed by this na, that is where I am making the mistake. All modern day compiler follows the right to left approach. Means what? First the argument that is the rightmost, that will be evaluated first. Means this one will be evaluated first. If this one is evaluated first, now we will get it correct. Forget about this part, this will be done later. So first this part will be evaluated. Here also I need to make some changes. It is initially having 10. Now it is incremented 10 PPP incremented. That means now it becomes 11. Currently it is having the value 11. Yes. Next, and after that, first this part will work. So minus star PPP, value at address PPP. What is that? It is not 12, sir. It is 11. Value at address 11. Value at address 11 is what? B. Now minus B means what? Sir, it will become A. Now A is coming. So here it will be A. After this, the other part is going to evaluate. So it is now this another part, that is this one. This will be evaluated. This is very dangerous one. You have to remember. Actually, I forget that. That's why it takes a bit time. Because in all previous example, we are calculating this thing normally, not inside a function. Suddenly, inside a function. Now you see, now this one will be evaluated. Now this one will be evaluated means, sir, again, same strategy, plus PPP. Then what is going to happen? Associativity right to left. This part first, followed by this part. Then you evaluate, sir, is equal to star means value at address. Then plus of PPP, Currently PPP value is what? 11. Plus of PPP means, sir, it will become 12. It will become 12. Now see, value at address 12. What is that? C. What is that? C. Now when it will be printed, this part giving me what value? C. This part giving me what value? A. That is the reason when we executed that, CA will come. but maybe in some compiler, guys, you can get CB as the answer also. But nowadays you are not going to get that CB because it is olden days compiler story, where maybe they used to consider as from the argument inside a function, they used to consider from left to right. But all modern day compiler nowadays consider the function argument from right to left. That is the one thing you have to remember whenever you are working with the concept of function, and you are having those statement which are evaluating inside a function argument. There you have to be a bit careful about that. What will be the order? The order will be all modern day compiler is right to left. Let us take the next one. Let me save that. Okay. Next one is simple. Suppose we are having int star ptr. Next one after that I'm writing star ptr is equal to 5. Next one after that printf %d star ptr. What is going to happen? Let us assume the options that are available here is option number A, compilation error. Is the code is going to give me compilation error or not? Option number B is runtime error. Option number C is 5. Option number D is none of these. These are my options. Right? Now what is going to happen? First you check syntactically any mistake is there or not. It's a simple statement, sir. Int star ptr, pointer to an integer, no question of having any syntactical mistake. Star ptr is equal to 5, that too is not having any syntactical mistake. And here it is a printf statement, that too is not having any syntactical mistake. So first point is going out of the window. That is no question of having compilation time error. But then where my coding is suffering, sir? Where my coding is suffering? Observe carefully here. Let me show you here. This is your coding. Now here, observe the first line. As per the first line, sir, what is going to happen? One pointer variable is going to be created. Next, this is the second line. Okay. Now observe carefully. When the first line will be evaluated, what I am supposed to do? Sir, a ptr variable will be created. What is the name? ptr. Every variable must have their own memory location. Here the memory location say 1000. But currently in the first line, did you initialize any value to this variable? Any initialization is happening? No initialization is happening. So that means what? Here what is the value we are having? Some garbage value we are having. Some garbage value we are having. Now when you evaluate this statement, star ptr is equal to 5. What it means? It means value at address equal to 5. Value at address this equal to 5. Now tell me what is this value at address this equal to 5? What is this part? Sir, this part is what? Garbage. So that means what you are telling? Value at garbage is equal to 5. But do you know what is that garbage value? Do you know that garbage value? If you know the garbage value, then it is never going to considered as garbage. What is called garbage value? Yeah, unknown value is considered as a garbage value. Garbage value means, sir, I don't know about the value. That is called garbage value. Unknown value is known as a garbage value. So you don't know what is that garbage value, sir. Then how you will assign that 5? So when you are going to get the problems, because syntactically everything is correct. If you see the if you compile the code, syntactically no problem. Syntactically no problem. Execute, just I'm compiling the code. Let's see syntactically any issue is there or not. Syntactically no problem. No error, no warning. But the problem at runtime, suppose guy I am asking you send this letter, then you are asking, sir, to whom to send? Then I'm telling I don't know. Then what I will do? It's exactly same. 5 value want to go. Then I'm asking, where the 5 will go? Then you are telling at the garbage address. At garbage address means I don't know which address 5 should go. Then where 5 will go? So when this assignment will work, assigning a value to a variable works when? At compilation time or at runtime? Sir, at runtime assigning take place, because compilation time means what, sir? Compilation time working means syntactical checking is done. If syntax is okay, then high level language is converted to low level language. That is the work that is done at the compilation time. But assigning, plus operation, multiplication operation, division operation, whatever the types of operations are there, when they are performed at runtime. So at runtime, how you will assign 5 if you don't know at which address you have to keep? That's the problem now. I'm calling you, you came, okay, fine. Send, I'm giving this letter and I'm asking, send this to, you're asking to, sir, I am saying, I don't know. Then what will happen? Problem will come now, sir. You will say, sir, then where I will send the letter? Same thing, where the 5 will go. So that is why in this code, the option is which one is correct, sir? Runtime error. The problem that will come is runtime error. At runtime, see, nothing is coming. Normally what happens when we compile a program, execute the program, it gives a message now, process exited with this, immediately it gives the process. Now see, it's working, it don't know where to work. After few minutes it is giving that. After few minutes it is giving that. So basically what is happening, sir? Nothing coming. I'm having a printf statement. In spite of that, nothing is coming, sir, in the console. So that is nothing but the indication of runtime error. That is nothing but the indication of runtime error. So the code is having where the issue? The code is suffering from runtime issue, sir. Next, and after that, let us take the next one. This one is also very, very easy. Observe here. Just if you draw the diagram, now you'll be able to solve each and everything, sir. Int a is equal to 36. Whenever you will get this type of problem, just immediately draw the diagram. Then int star ptr. Done. Then ptr is equal to ampersand. We observe here, I'm capturing the address. That is the thing that was not happening in the previous example. That's why that runtime error came, sir. Percentile u and then percentile u. To address I want to print. Here I'm writing star followed by ampersand, and here I'm writing ampersand followed by star. Star followed by ampersand and ampersand followed by star. Now my question is, ultimately, what is going to be printed? Option number A. First one will print address, next one will print value. Option B. First one will print value, next one will print address. Option C. First one will print address, next one will print address. Option D. Compilation error. Sir, no question of having any compilation error, because syntactically I have never made any mistake here. All the lines are okay. So no, acha, this one I have to complete. This is star ampersand star ptr. Syntactically code is perfectly okay, sir. So no question of compilation error. I have to just evaluate and have to conclude whether I'm going to get value, address, value, address, or address, value. Let's see. So this is what. Let me save this one. (146). Next file. Next one, sir. Observe here. First line, just a variable declaration with memory. Another line, just the pointer variable declaration currently having the garbage value. Done. And this is the one I have to work, sir. Observe here, first line, sir, variable declared. What is the name? A. What is the value? 36. What is the address? Some 100. Some 100. Okay, let's see, Ayush. We will reach to the conclusion. Next is ptr. ptr is the pointer variable who can hold the address of an integer here. That's why int star ptr. At this line, what is the value? Garbage. Currently garbage. Next, when ptr is equal to ampersand a will work. Now the garbage will overwrite. Now the garbage will override by what? Address of A. What is address of A? 100. What is the address of A? 100. Next, sir. Come and evaluate this one. Come and evaluate this one, sir. Okay, no problem. How many operator is there? 2. Sir, both are having same precedence. Really, sir? That's why precedence and associativity table is very, very important. This is precedence and associativity table. See star and ampersand in the same level now. I don't think, sir, you wrote star first, that's why star is fast. No, 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 no. Inside a block, all of them are having same precedence. In this block, all of them are having same precedence. Then what I have to do when same precedence is same, I have to go for associativity. Associativity is right to left. So right to left means, sir, how the expression will be bracketized. Expression will be bracketized right to left because your associativity itself is right to left. Then what happened? Sir, first this part and then this part, then this part. Now what is going to happen? Sir, value at address done. Then what is there? Address of PTR. Address of PTR is what? Suppose for example, PTR having its own address as 4000 or 400, something like that. PTR is having own address. So value at address done. Then what I am writing? Not PTR, guys. Observe carefully. Ampersand PTR. That means address of PTR. Sir, address of PTR is what, sir? 400. Address of PTR is what? 400. Now what you are saying? Value address of PTR. Ampersand PTR means address of PTR. Address of PTR is what? 400. Now value at address 400. What is the value at address 400? What is the value at address 400? 100. Is this 100? Is it a value or it's a address? Is this 100 is a value or it is an address? Tell me. It's an address, sir. So that means what? That basically means what, sir? Currently, for the first one, I'm not going to get any value. What I'm going to get? Address. Ayush, understanding? It's not value, sir. It's a address. This 100 is a value or address? Sir, it is the address, sir. It is the address. This one is address. Let's take the next one, sir. Star and ampersand and star. No problem. Again, associativity precedence, sir, precedence same. Then associativity. Associativity, sir. Let's bracketize the expression star ampersand star PTR. If I do bracketize this part first and then this part, then this part is equal to ampersand means address, address of whose address. Then you are telling star PTR. Star PTR means value at address. That's the meaning of star. Then PTR. PTR means what, sir? 100. PTR means what? 100. So value at address 100. Value at address 100 is what? Sir, value at address 100 is 36. Now what you are telling? Now what you are telling? Address of 36. Address of 36 is what? 100. 36 address is what? 100. Address of the 36 is what? 100. So that means what? It is in both the cases, it is giving me what thing, sir? In both the cases, it is giving me address value. This one is address, this one is address. Ayush, understanding? In both the cases, in both the cases, it is address, sir. So which option is correct? Sir, option number C is correct. Address, address. Next and after that, file, save as. Next, sir. What is the next one? Again, very simple one. Observe carefully. I'm taking a variable here. Say for example, num. Int num equal to some value, say 10. Then printf, what I'm going to write, num is equal to %d. Then I'm writing address of num is equal to, for printing address we will use %u. That is what you have to remember. Why, sir? Because %u means unsigned. Unsigned means no sign. No sign will come into the picture. Always will be positive. Address cannot be negative, na guys. Address cannot be negative. That's why for printing we always use %u, which is for unsigned integer. But number can be, yeah, number can be negative, sir. Positive number or negative number. That's why %d. D stands for decimal. Then here I'm writing num and here I'm writing ampersand num. Oh, very simple, sir. The value and the corresponding address will be printed. What is the issue here, sir? No problem. Next, and after that, I'm writing here num plus plus. Then again, I'm having a printf statement here, where I'm having a /n, so that it will go to the next line. Num, address of num, remaining things are same. So here I want to know what is going to happen, sir. Say first option is option number A, compilation error. Option number B, num is or num equal to 10. Address of num equal to some value, some arbitrarily value. When we run the application, we don't know which value will come. Just arbitrarily we are taking some value. Num is 10 and address of num is this. For the second line, num equal to 11 and address of num equal to, here say 38. Next, option number C. Option number C is what? Almost same. Here it is, I'm taking 40. Option number D is almost same, and only thing is that here I'm taking 36. Tell me which option is correct one. Which option is correct one? No, Ankita, num is not a pointer variable. Num is a normal integer variable. So now if you observe here, it's not a pointer variable, na. Now if you observe here, file, new. Sir, this is my code, right? First line, this is one important line, this is another important line. Now observe first line. What will happen? Sir, one variable will be created. What is the name of the variable? Num. What is the value? 10. What is the address? Let us take some arbitrary address. I'm taking whatever they are giving. I'm considering that address. Yes, now you people made the correct answer. It's D. Suppose this is the address. So num is equal to what now? 10. Address will be this one. Next, num plus plus. Num plus plus means, sir, num will increment. Is the address will increment or the value will increment? Sir, value will increment. So your address is going to change or it will be same? Sir, the address will be same. It's not going to differ. Now you see here, of course, you will not get that 36. When we will compile and run, we will get different address. But the thing is that the address will be same, sir. Whatever address will come, that will be same. 36 will come or not, that guarantee will not be able to give. Some address will come and that will be same. So as for our example, which address came? 80. But the thing is that in both the cases, the addresses are same. So which option is correct one? Option number D, not option number C. Understanding? Getting the clarity? Yes. So this is done. Next and after that, next one. Let me provide you the next one. 1 minute. Yeah. Next one everyone should do, right? Just if you draw the diagram, you'll be able to do that. Have a look next one. Sir, int I is equal to 25. Done. Just draw the diagram. That's it. Int star j. That's it. No problem. Wherever I write star, not an issue. I can write it with by touching with j, or even I can touch it with data type. Not an issue. K is equal to ampersand j. Done. Printf. Here I am having percentile u, percentile u, percentile u, and here I am printing k star k star star k. My options are option number A, address value, address value. Three things we are printing now. Next and after that, option number B is address value. C, address. D, compilation time error. Compilation error. Now syntactically I have not made any mistake, so no question of compilation error, right? Let's see what we are going to get. First line, second line, third line, fourth line, and this is the fifth line. Okay, sir, first int I is equal to 25. No problem. Just one variable I, value is what? 25 with some address. Let it be 400. Next, sir, j, another variable. That means having its own memory location. Currently I didn't assign anything to j. J is having what value, sir? Garbage value, and it's having some address, own address, 600. Next, we are having k. That means another variable. Here also at this line, I didn't initialize anything to k. K is also having garbage and some address, that it be 800. Done. Now I am doing this, sir. K is equal to ampersand j. That means what will happen? Sir, address of j will be given to k. What is address of j? Address of j is 600. So that will be given to k. So automatically it will become what? 600. It will become what? 600. Now you see, sir, first what it is printing? K. That means 600. Address. Next one is what? Star k. Means what? Value at address 600. Value at address 600. Yes, correct. Ayush, your answer is correct. Value at address 600 is what, sir? That's a garbage value. Value at address 600 is what? That's a garbage value. And lastly, sir, star k. Star k means value at address. Achha, here I missed one line, guys. 1 minute. I missed one line. J is equal to ampersand I missed. 1 minute. Here I missed one line. Say this one. J is equal to ampersand I. So this line will execute first before K is equal to ampersand J. No problem. J is equal to ampersand I means what, sir? This address of I 400, na? This will be coming here, sir. This will be coming here. Now you see everything. Sir, K 600. Star K 400. Star K is star K is what? See, observe. K means 600. 600 is a value or address? Address. Star K means, sir, this 400. 400 is value or address? Address. Star K means 25. 25 is value or address? Value. So that means what? Which option is correct? Which option is correct? Address, value. Which option is correct? Address, value. Everyone got clarity? Everyone got clarity about this one? Now you can understand how the pointer related example you have to solve. And you see another thing here. Sir, why the type of K is 2 star? See, J is capable of holding address of an integer. That's why int star. K is capable of holding address of J, which is already 1 int star is there. So that means how many star is required? 2 star. When I hold address of I, no star is there. That's why myself is 1 star. Someone is taking my address. Then how many star is needed? 2 star. If someone is taking K's address, how many star will be needed? 3 stars, sir. Understanding? That's it, sir. So next week when we'll meet, no, next week, not next week, tomorrow. Tomorrow we have the class, no? Yeah. No, Ayush, if it is only star K, it will not give any error, but it will give you warning. If you only write star K, na, you are making mistake. But for that, you are not going to get any compilation time error. Only compiler will do it, will tell you what? It's an incompatible type. Don't do this type of stuff. Warning it will provide. See, it is giving warning. Where it is giving warning? Here. First, say for example, K is equal to ampersand Z. So let me comment this line. Int star K I'm taking. Execute, compile and run. It directly giving error. And see what it is giving the error. Read it. Cannot convert. Read it. Int star to int star. Why? See, already we know int I is equal to 25. There, type of I is what? Int. But type of ampersand I is what? Int star. It is int star. Similarly, when you say type of J is what? Sir, int star. Then type of ampersand J is what? Type of ampersand J is what? Int star. Int star. Now, that's why it is telling cannot convert int star because type of ampersand J is what? Int star. But type of K is what? Int star. Cannot convert int star to int star. Understanding? The meaning of the error is meaningful. The way the error is giving meaningful, because already we know that, sir. Type of integer is int, but type of ampersand of that is int star. Type of J is here int star. Then type of ampersand J double star. So that's why if we write like this, definitely we are going to face the problem. Understanding? Yeah. So tomorrow we will meet. We will go for practicing few more examples with respect to this pointer, so that we can get the clarity, more clarity. And next week we will start discussing on string concept. Yeah. Thank you, guys.